So, in our previous class, we are discussing about the p-n junction. Actually, not discussing. We are recollecting our memory of p-n junction. What is p-n junction? So, again, what is a p-type semiconductor? P-type semiconductor means where holes predominates, and the n-type semiconductor means where electrons predominates. If let us go to the electrical properties. Now, in case of semiconductor, what will happen? If let us suppose this is a semiconductor. This is a semiconductor. Here, this is a semiconductor. These circles are for silicon. This circle are for silicon. This is silicon. Hey, তোমরা দেখছো?
Presentation হচ্ছে না স্যার।
ও আচ্ছা আচ্ছা আচ্ছা। কিভাবে স্টপ হয়ে গেল? ওকে, শেয়ার স্ক্রিন। নাও ওকে, এখন দেখা যাচ্ছে তো না?
Yes sir.
হ্যাঁ হ্যাঁ। Let us suppose this is a semiconductor. All these circles are your silicon. All the circles are silicon. So if you take an individual, silicon, this is silicon, and it has 4 electrons in its outermost orbit. One here, one from here, one from here, and another one from upper side. That is from here. Another one from upper side. Let us here. This is silicon. Now, if we consider this silicon, you see it has 4 electrons in its outermost orbit, and another 4 it shares with its neighboring atoms. Another 4 it shares with its neighboring atoms. So this silicon has 8 electrons, and it is satisfied. Okay. But if I replace this silicon with a phosphorus, say for example, this is phosphorus. Say for example, this is phosphorus. Now, in phosphorus, there are 5 electrons in the outermost orbit. Say for example, this is phosphorus, and it has 1 more electron in its outermost orbit. Say for example, this is, I change the color. If I change the color of it, just like that. In case of phosphorus, there is another electron. Actually, 5 electrons in the outermost shell. These are the 5 electrons. Now, here also, this is phosphorus. Here also, you will find the 5th electron Here also you will find the fifth electron. Here you will find the fifth electron, as because the red one is phosphorus, so you will find the fifth electron here. Now, there is no place of this electron. You see, there is no place of this electron. Here, there is 8 electron of the phosphorus. There are 8 electrons of the phosphorus. So the phosphorus is satisfied. Now, this electron of phosphorus is alone. So it becomes free. It becomes free to move. It becomes free to move here and there, here and there, here and there. It becomes free to move anywhere in the crystal. That is called electrons. It is now here, and it becomes free to, it is free to move anywhere. It is free to move anywhere. So if there is another phosphorus atom here, if there is another phosphorus atom here, the shape field is red. If another phosphorus atom here, if another phosphorus atom here, so you will find more electrons. So you will find 3 electrons, those are free. You will find 3 electrons, this one, and this one. Those are free. They can conduct electricity easily. Why? Because they are free. They can go to their conduction band from the valence band. Say, for example, this is the valence band. For example, say this is the valence band. This is the valence band, and this is the conduction band. This is the conduction band. Conduction band is your empty. This is the conduction band. So in case of this free electron, the band gap between the valence band and conduction band is very small. Why? Because these electrons are free. But in case of silicon, if we again draw this, say, for example, this is silicon. The band gap is like that. So what I want to say that for transition of this electron from valence band, this electron means this extra electron, for transition of this extra electron from valence band to conduction band, the band gap is very small. If you give slight energy, it can transit from valence band to conduction band. It can go from valence band to conduction band. But if you see the case of this electron, the normal electron of silicon, the band gap is higher than this. It is about, say, for example, the band gap is about 1.1 electron volt. And for this, it is about 0.1 electron volt or 0.2 electron volt. This band gap is very small compared to the normal band gap of silicon, a normal band gap of this red electrons. So here are two types of electrons. In this case, there are two types of electrons. One is the free electron. It can transit from valence band to conduction band very easily. And another one is normal electron of silicon. It can transit from valence band to conduction band with some energy. Say for example, it is in case of silicon, it is 1.1 electron volt, or in case of germanium, it is 0.3 or 0.4 electron volts. So there are two types of electrons. Now, if one electron from here, say for example, one electron from here, one electron say from here, it will be here. It goes from valence band to conduction band. So here an empty space occurred. You will find the empty space here because from this space, one electron from this space, the electron of this space will go from valence band to, or went from valence band to conduction band. So you will find an empty space here. This empty space is known as hole. This empty space, if we shape fill, no fill, this is an empty space. This empty space is known as hole. This empty space. Why it is empty? Because from here an electron goes to the conduction band. So there is a hole. If from here one electron goes from valence band to conduction band, you will find a hole here also. You will find a hole here also. Okay, you can assume it. You will find a hole here also. You will find a hole here also. So two electrons transited from valence band to conduction band. We got two holes. Here. One is here and another one is here. Now, what will be the actual transition? You see, from here, one electron transited from valence band to conduction band very easily. From here, one electron transited from valence band to conduction band very easily. From here, this electron transited from valence band to conduction band very easily. And from here and from here, two electrons transited from valence band to conduction band with 1.1 electron volt energy. So we can get 5 electrons here and 2 holes here. You see, 2 holes here. One hole is this hole, one is this hole, and another one is this hole. So we get 5 electrons in the conduction band and 2 holes in the valence band. These holes are in the valence band. Okay. Now, electrons can carry the electricity, and hole also can carry the electricity. How it can carry the electricity? You see, this electron falls into this hole, and this hole goes to here. Now, this electron falls into this hole, and this hole comes here. This electron can fall into the hole, and this hole come here. So hole can move, and the electricity moves with the positive charge. That means the electricity moves in the direction of the movement of positive charge and opposite to the direction of your electron. Electricity generally moves in the direction of positive charge and opposite to direction of electron. So here there are 2 types of carrier of electricity. One carrier is electron. It can carry electricity. How? By moving from valence band to transition band. Conduction, not a transition band, valence band to conduction band. But hole also can move. Hole also can move. So what will be the majority carrier? Who is the majority carrier? The majority carrier here is the electrons, because there are 5 electrons. So majority carrier of electricity is the electron here. And the minority carrier of electricity is the hole in this type of semiconductor. In this type of semiconductor, it is which type of semiconductor? It is N type of semiconductor. Because why it is N type of semiconductor? Because the electrons are majority carrier. It is N type of semiconductor because the electrons are majority carrier. How electrons are majority carrier? Because there are 5 electrons in the conduction cell and 2 holes in the valence shell. Both are conducting electricity. As because the number of electron is 5, so electron carries the electricity. Majority electricity is carried by electron, and minority electricity is carried by hole. So both are conducting electricity, both are carrying electricity, but majority of electricity is carried by electron, and the minority portion is carried by hole. So in case of N-type semiconductor, the majority carrier is electron and the minority carrier is hole. Now, if we see the case of P-type semiconductor, what are the P-type semiconductors? For example, it is like this. Shape outline is this. It's not changing. Shape fill. Like that. These are the +3. These are the +3. So what will be the structure of +3? We will find 3 electrons in the outermost orbit, For example, it is aluminum. For example, these are aluminum. So you will find 3 electrons in the outermost orbit, not 4 electrons. So say, for example, this electron, there is no this electron, there is no this electron, and there is no this electron. So you will find a hole here, you will find a hole here, and you will find a hole here. 1 electron less. So you will find a hole here, you will find a hole here, you will find a hole here. If 1 electron comes from here to here, then hole is here. If 1 electron comes from here to here, then hole is here. If 1 electron comes from here to here, then hole is here. So hole can move. Hole can move. Now, you'll find 3 holes for 3 aluminum and 2 other holes. Where? 2 other holes. One is here and one is here. Why this hole? This is the electrons. This is the electrons of silicon that has gone from valence band to conduction band. That has gone from valence band to conduction band. 1 electron from here that has gone from valence band to conduction band, and here it is another electron that has gone to valence band to conduction band. Now, how many electrons are in the conduction band? Can anyone tell me? How many electrons are in the conduction band? Can anyone tell me? Two electrons. 2 electrons. And how many holes are in the valence band? Why? Here is 1 hole. Here is 1 hole. Here is 1 hole. Here is 1 hole. And here is 1. 2 holes for these 2 electrons. And 3 holes for these 3 aluminum. So you'll find 5 holes and 2 electrons. We know both holes and electrons can carry the electricity. Both holes and electrons can carry the electricity. Here, number of hole is 5, but number of electron is 2. So the majority carrier is now hole, and the minority carrier is now electron. Hole is positively charged because 1 electron is less here. Say this is the hole. So 1 electron is less, so it is positively charged. Hole is positively charged. So there are 5 holes. The majority carrier is hole. So the majority carrier is positively charged. So it is p-type semiconductor. And the minority carrier is electron. The minority carrier is electron because it has 2 electrons. So we saw in n-type semiconductor, in case of n-type semiconductor, there are 5 electrons which are conducting electricity and 2 holes that are conducting electricity. But in case of p-type semiconductor, we see that there are 5 holes and 2 electrons. So in n-type semiconductor, the majority carrier is electron and the minority carrier is hole. But in p-type semiconductor, the majority carrier is hole and the minority carrier is electron. So in case of p-type semiconductor, positive charges prevailed. And in n-type semiconductor, electrons prevail. Number of electrons is large. And in p-type semiconductor, number of hole is large. Number of positive charge is large. কে বুঝো নাই বলো দেখি আমাকে, কে বুঝো নাই আমাকে বলো একটু, যে which one is the majority carrier and which one is the minority carrier? Huh? What is p-type semiconductor? What is n-type semiconductor? And what is semiconductor itself? Semiconductor, what is semiconductor? Those materials which have a small band gap. That is semiconductor. And with the large band gap, that is insulator. And that is no, if there is no band gap, that is metal. হ্যাঁ, সবাই বুঝেছ? বুঝো নাই এমন কেউ আসো? দেখো এটা যদি না বুঝো, এর পরের আমার অপটোইলেকট্রনিক ম্যাটেরিয়াল কিছু বুঝবে না। এইটা আগে তোমাদের মাথার ভিতর ঢুকে যেতে হবে, তারপর তুমি অপটোইলেকট্রনিক ম্যাটেরিয়াল বুঝবে। আদারওয়াইজ অপটোইলেকট্রনিক ম্যাটেরিয়াল আর অপটোইলেকট্রনিক ডিভাইস এগুলো কিছুই বুঝবে না। আমরা ৬-৭টা ডিভাইসের কথা পড়বো, হ্যাঁ, তোমরা এগুলো কিছুই বুঝবে না যদি এইটা না বুঝো। কারণ যদি কনফিউশন থাকে আমাকে বলো, এখন আমি আবার ক্লিয়ার করে দিচ্ছি কোথাও যদি কনফিউশন থাকে। ওকে, সবাই বুঝেছ? এমন ভাবে বসে আছো যে আমি কি বললাম আর তোমরা কি বললে, এটা তো কিছুই নাই। বুঝলে অন্তত মাথা তো নাড়বে অথবা কিছু বলবে। হ্যাঁ
জি স্যার, বুঝেছি স্যার।
হ্যাঁ, কিছু তো মাথা অন্তত নাড়ো, বলতে না পারলে মাথা অন্তত নাড়ো। কিন্তু তোমরা স্টিল বুঝেছো, স্টিল বসে আছে, বুঝলে, স্টিল বসে আছে। হ্যাঁ
কোশ্চেন ছিল স্যার।
হ্যাঁ বলো।
স্যার আমাদের এই যে পি টাইপ এবং এন টাইপের মধ্যে তো স্যার দুই ধরনের ক্যারিয়ার, একটা হচ্ছে হোল আর একটা হচ্ছে ইলেকট্রন।
না, দুইটাতেই দুই ধরনের ক্যারিয়ার নয়, দুইটাতেই হোল আছে। You will find hole in p-type and in n-type also. But in n-type, the hole is minority, and the p-type hole is majority.
স্যার এই দুইটা কি স্যার মেজর এবং মাইনর যে আপনার ক্যারিয়ার গুলো স্যার, এগুলো কি মানে আমরা যখন ইলেকট্রিসিটি ফ্লো করতে চাইবো তখন কোনো মানে এনার্জিটা ঠিক থাকবে কিনা? যেমন ধরেন আমরা যদি এন টাইপ নেই তাহলে স্যার ইলেকট্রনটা বেশি থাকতেছে,
হ্যাঁ,
আবার হচ্ছে যদি পি টাইপ নেই তাহলে হচ্ছে হোলটা বেশি থাকবে,
বেশি থাকবে।
তাহলে সেম ইলেকট্রিসিটি যদি আমি ফ্লো করি তাহলে স্যার দুটার মধ্যে কি আমরা সেম এনার্জি পাবো কিনা বা সেম ফ্লোটা পাবো কিনা?
সেম ফ্লো পাবো কিনা? আচ্ছা, অ্যাকচুয়ালি ইলেকট্রিসিটি ফ্লো করছে কে? মুভমেন্ট অফ ইলেকট্রনের জন্যই তো ইলেকট্রিসিটি ফ্লো করছে, তাই না? আমরা বলছি we are telling that hole is carrying electricity or electron is carrying electricity. Actually, in both the cases, electricity is due to the electron. In both cases, you see, একটা কেজে কি করছে, ইলেকট্রন ফ্রিলি মুভ করছে, আর একটা কেজে ইলেকট্রন কি করছে, হোল থেকে হোলে যাচ্ছে, হোল থেকে হোলে যাচ্ছে। ফর দ্যাট we are getting electricity. But to differentiate these two, we are telling that hole is carrying electricity, and in this case, electron is carrying electricity. Actually, we are finding electricity for the movement of electron in both cases. So the energy of electricity or the type of electricity is same in both cases, because in both cases we are getting electricity for the movement of electron. But to differentiate between the two, one is free electron, another one is not free electron. It is jumping from one hole to another hole, from one hole to another hole. To differentiate these two, we are telling that in one case the hole is carrying electricity, in another case the electron is carrying electricity. বুঝতে পেরেছো?
জি স্যার, বুঝতে
হ্যাঁ, তোমার এনার্জি ডিফারেন্স হবে না, বিকজ দুইটা জিনিস ইলেকট্রিসিটি ক্যারি করছে না, ইলেকট্রনই ইলেকট্রিসিটি ক্যারি করছে ইন বোথ দ্য কেস। আর কারো কোনো কোয়েশ্চেন আছে? ভেরি গুড। নাও আরেকটু ডিপে যাচ্ছি আমরা একটু। Now what will happen if we connect an N-type semiconductor with a P-type semiconductor? For example, this is a P-type semiconductor. For example, this is a P-type semiconductor. And this is N-type. This is N-type. This is N-type. So this is a P-type semiconductor, and this is N-type semiconductor. We have attached a P-type semiconductor with an N-type semiconductor. This is the junction between P-type semiconductor and N-type semiconductor. This is the junction. We call it the PN junction. We can call it a PN junction. PN junction. PN junction. Now, what are these green dots? Can you tell me what are these green dots?
holes, sir.
This is holes. These are holes, and these are obviously electrons. As because it is N-type, these are electrons, and these are holes. Now, in P-type semiconductor, there are holes. In N-type semiconductor, there are electrons. Is there any other substances here? Is there any other thing here? Is there any other thing here?
Silicon to sir,
Obviously. Say, for example, this is hole, and for that, say, for example, this is electron. But the main thing is the silicon. The main thing is silicon. So silicon is everywhere. Silicon is everywhere. In this side, there are some number of holes, and in this side, there are some number of electrons, extra electrons. Why? Due to the doping of, say, phosphorus. Phosphorus has +5, So extra electrons are these extra electrons are red, and and in this side, say there are aluminum. So one electron is less in the aluminum. So you will find the holes here. Now, if we connect this, what will happen? What will happen? These are the free electrons. These are the negatively charged, as because these are the free electrons. And these are the holes. These are positively charged. So holes will attract the electrons. Holes will attract the electrons. Holes will attract the electrons. These holes will attract these electrons. This hole will attract the electrons. And this holes also will attract the electrons. This holes also will attract the electrons. Now, what are these substances? Can you tell anyone what are these substances? What are these substances?
Positive charge.
No, how it will be positive charge? This was positive charge. Say this hole is positively charged. When an electron enters here, will there be any positive charge? There will not be any positively charged. There will not be any positive charge. There will not be any positive charge. But now this is a neutral molecule. Now this is a neutral molecule. Here also we shall find the neutral molecule. Here also we shall find the neutral, because there is an extra electron here. The electron goes from this side to this side. So we will find here a neutral molecule. Here some neutral molecules. And here also we shall find the neutral molecules. Here also we shall find the neutral molecules. These are the neutral molecules. So we lift them from here. So these are the neutral molecules. Here all neutral molecules. All neutral molecules. Now, what do you mean by neutral molecules now? Say, for example, aluminum. Aluminum has 3 electrons in the outermost orbit. Is it correct? Aluminum has 3 electrons in the outermost orbit. And phosphorus have 5 electrons in the outermost orbit. Now, one of the phosphorus electron, these are the electrons of phosphorus. One of the electron from phosphorus enters to the aluminum. One of the electron from phosphorus enters to the aluminum. This is aluminum. This green is aluminum. One of the phosphorus electron enters to the aluminum. Now, what will happen? The number of electron of phosphorus will be now 4. And the number of electron of aluminum is now 4. Okay. One of the electron from phosphorus goes from here to here, uh, goes from here to here. Now the number of electron in phosphorus is now 4, and the number of electron in aluminum is now 4. But aluminum has 3 electrons in the outermost orbit. A neutral aluminum has 3 electrons in the outermost orbit. So when a phosphorus electron enters to the aluminum atom, the aluminum becomes negatively charged and the phosphorus becomes positively charged. Okay, এটা কি বুঝেছো? Phosphorus becomes positively charged and aluminum becomes negatively charged. এটা কি বুঝেছো?
Yes, sir.
As because one electron of phosphorus goes from this side to this side and enters into the aluminum. So here say 1, 2, 3, 4, 5, 6, 7, 8, 16 electrons from phosphorus enters to the aluminum. So we'll find 16 negative charges here. It is a zone of negative charge. 16 negative charges here. Can I write negative charges here? How can I write? Yes, it is a zone of negative charge here, and it is a zone of positive charges. It is a zone of positive charges. So if now one electron tries to go to this side, this negative charge will repel this electron and it will come back again here. In these two cases, it was not happened. It was not happened because there was no zone of negative charge or no zone of positive charges. But now there becomes two zone of negative charge and positive charge. These zones of positive charge and negative charge is like a barrier. It's like a barrier. To whom? To electron that wants to go here. Because when this electron wants to go here, this zone of negative charge repels this electron and it will back again to its original position. Now, if one hole wants to come here, this zone of positive charge repels this and it will go back to here. So there becomes a potential barrier. This is a potential barrier. That became a potential barrier here. And this region is known as depletion region. This region is known as this region is known as depletion region. Why depletion region? Depletion region. Because why depletion region? Because here some electrons and holes are depleted. These electrons and holes are depleted. Depleted means becomes neutral atom. There are some electrons here and there are some holes here. They are depleted and this becomes this place is become neutral zone. This is now this is now is a neutral zone. This is now a neutral zone. This is now a neutral zone. Here only silicon is there, nothing else. Only silicon is here and nothing else. Nothing else. Now, what will happen? What will happen if we give we connect a battery to it? We connect a battery to it. So we draw this depletion region again. We draw this. Okay. Now this is the depletion zone. This is the depletion zone. This is the depletion zone. Here only your silicon is here. Only silicon is here. Only silicon is here. In this zone, only silicon is here. Now, what will happen? What will happen if we connect a battery to it? This is negative side and this is positive side. We can write here. We can write here. This is positive. This is positive side, and this is negative side. This is negative side and this is positive side. Then what will happen? You see, these are the positive. These positive holes, and these are the negative charges. So this is the negative. That means the negative side of the battery, that is electron, will flow to this side to here. Then from battery, electron will come by this side to this. And from battery, the positive charge will come to this side to this. Now, if electron comes from this side to this, it will repel these electrons, or this electron will push this electron. This electron will push this electron, and this positive charge of the battery will push this positive charge. Now, say for example, this electron is pushing this. This will push this, 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 and this will push towards itself, towards this way. But there is a negative region. There is a negative region. If we see here, there is a negative region. There is a negative region. There is a negative. If we copy it from here to here, There is a negative region. Now, electron wants to come here, but the negative charge repels this electron to its own position. Now, if the energy of this battery is sufficient, then these electrons or all these electrons will go towards itself. All this electron will go towards itself. Say this potential barrier, this is if this is silicon, the potential barrier is 0.7 electron volt. If this is silicon, sorry, not electron volt, 0.7 volt. Actually 0.7 volt, sorry, 0.7 volt. This depletion region, this barrier is 0.7 volt. If the strength of battery, say for example, this battery is of say 1.2 volt. So is the strength of this battery is higher than this depletion region. So it can give 1.2 volt energy to these electrons. So this electron can pass through this easily. This electron can pass through this easily and combines with the hole. And these holes can also pass through this easily and combines to hole. So, so this electron can pass through easily, and this is repelling, and this will go this way, 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 and this way again. This electron also will go this way, this way. So you will find the electricity. You will find electricity from this through this way, because electron is moving. Sorry, not this way. You'll find this electricity to this way. Because electron is moving to this, you will find opposite electricity in opposite direction. Now, what will happen if the battery is changed? Say for example, positive becomes negative, and this negative becomes positive. What will happen? Say for example, if this is longer than this. Now what will happen? This positive will attract these electrons towards itself. This electron will come through this way. This electron will come to this way. Sorry, this electron will come to this way, because this is positive charge. Positive charge will attract these electrons. So so accordingly, this will also go there. 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 This will also go there, and this will also go there. These electrons will also these electrons will also go to this side, and this is negative So these electrons will also go to this side. What does it mean? The depletion region is now becomes larger. The depletion region is now becomes larger, and you will find no electricity. Can you find any electricity? No, you will find no electricity. So this is called reverse bias. This is known as reverse biased. And the previous one is forward bias. The previous one is forward biased. Which one is forward biased? This is forward biased, and this is reverse biased. And in you can do biasing by just changing the positive and negative side of the battery. So in a PN junction, you will find forward bias and reverse bias. In case of forward bias, the positive charge and negative charge coming closer together, and you will find electricity. And in case of reverse bias, the positive charge and negative charge are distancing apart, and you will not find any electricity. So these PN junctions are known as diode. These PN junctions are known as diode. These PN junctions are known as diode. Why this called diode? Because two 1p and 1 and joined together, so it is called diode. Now electricity will go in which way? Which way electricity will go? কেউ বলতে পারবে? Which way electricity will go? Here. This way electricity will go, or this way? Which way electricity will go? Which way electrons are going? From this way to this way. So you'll find electricity from P to N. From P to N. You will find electricity from P to N. Okay, this is another thing. This is of semiconductor thing. So this is a PN junction. Now let us go to the let us copy it and go to our slide. Now, first application you can see in photoconductivity. We saw previously the luminescence. Luminescence we saw photovoltaic instrument, luminescence. And now we see the photoconductivity. What is the main thing? What is the basics of photoconductivity? Now, if we say if we connect this by reverse bias, say for example, if we connect this by reverse biasing, this is reverse bias. This is positive charge and this is negative charge. Now, what will happen if we connect this by reverse bias? You will find a large depletion region. Okay, you will find a large depletion region for reverse bias. Now, how large? What it is like this or more big? It will depend on the battery. It will depend on the battery. If the strength of battery is higher, then the largeness of the depletion regions becomes higher. It will depend on the battery how large it will be. Now, the depletion region becomes large. In this depletion region, there are only silicon atoms, nothing else. In this depletion region, there are only silicon atoms, nothing else. Now, if light falls here, say, do we have any arrow? If light falls here, oh no, it is not arrow. Okay. If light falls here, say for example, light falls here. Say for example, sunlight. If light falls here, sunlight. Say for example, this is silicon. The band gap of silicon is 1.1 electron volt, and the energy of sunlight is 1.8 to 3.2 electron volt. So what will happen? The electron of the silicon will go to the conduction band or it becomes free. The electron of the silicon will go to the conduction band or the electron of the silicon will become free because the energy of sunlight is greater than its band gap. Okay. Now, in reverse biasing, here you see there will be no current. There is no current flowing here. In reverse bias, no current flowing here. In forward bias, there will be a current. There is current. But in reverse bias, there is no current. Now, this slide produces electrons. This slide produces electrons. This slide produces electrons. How it produces electrons? This slide produces one photon produces one electron. How? By exciting the silicon electron from valence band to conduction band. Now, this is the positively charged. This is positively charged. This is positive charge here because it is reverse bias. So here positive charge here. This electron will go from this side to this side, and you will find a current. So in a reverse biased diode, where there was no current, after falling light on it, you will find current. You will find current. You will find current. You will find current here, like this, like this, like this. You will find current here. So if three light falls, 3 photon falls, you will find 3 electrons which will give you current. So a photodetector or by a photodetector, you can detect light. By a photodetector, you can detect light. How? Because in this diode there is no current. In this diode there is no current, but when light falls here, electrons, you are getting electrons from the silicon atom, and this electron will flow and you will get current. Okay, এটা সবাই বুঝেছো? What is photodetector? What is the principle of photodetector? সবাই বুঝেছো?
Yes, sir.
Very good. This is called photoconductivity, and this is photodetection. Okay. Now, what will happen by this photodetector? Huh? Say this is, there is no current here. If light falls here, current starts flowing. That means it is a switch. There is no current here. If you allow to fall light here, then the current start flowing. So it is a switch. Okay. Now, your television, there is no current now. And from your infrared, from your remote control, you passed the infrared light to here. From your remote control, you will see the head of the remote. In the head of the remote control, there is a portion like a bulb. You are passing infrared light to this opening, to this bulb-like opening. It comes to here, and it started the flowing current, and it switched on your television. So your your television in the switch in your television, there is a photo detector which you can start by pressing your remote control, by pressing your remote control. Now you can use it by reversing this also. How you can use it by reversing it? Say for example, you are allowing infrared light falling. You are allowing infrared light to fall here always. You are allowing the infrared light to fall here always. Let us suppose if we draw another suppose one slide. Let us suppose this is a photo detector. Let us suppose this is a photo detector, and you are this is an infrared source of light, and you are giving this you are passing infrared light always to this photo detector. Okay, one will be enough. You are passing infrared light always to this photo detector. Now what will happen? What will happen? You will find always you will find current always here. Okay, if you pass light here always, so you will find current always here. Okay, now let us suppose this is your door of your house. Let us suppose this is a door of your house. This is a door of your house. This is a door of your house. Let us suppose. And you do not allow to anybody to pass your door. You do not want to allow anybody to pass your door because you are not in your house. So you do not want to allow anybody to pass your house. Now, say for example, this is a thief. This is a thief. This is a thief. He wants to enter in your door. Now, he wants to enter in your door. And when he comes here, it obstacles the infrared light. Now, there will be no current here. Now, there will be no current here. So no current will be here. No current will be here because no infrared light falls here. So no current will be here. And you have set an alarm. Say, for example, this is an alarm. You have set an alarm such that if there is no current, the alarm will cry. So if anybody wants to enter in your house, you will find an alarm crying. Because why? Why? Because this infrared light, this thief is obstructing this infrared light, and you are not getting any current here. So alarm is crying that I am not getting any current. So then and then you can tell somebody is obstructing the way of this infrared light, and you can take the measure for that. This is the alarm. This is the alarm by using your photo conductivity or photovoltaic cell. জিনিসটা বুঝতে পেরেছ? Now, third one. Let us suppose that this is a metal archway. This is a metal archway. If you want to pass this archway, pass this metal archway, you get a crack blip. তোমরা সবাই আর্চওয়ে পাস করেছো না? মেটাল আর্চওয়ে পাস করেছো না? হ্যাঁ, আর্চওয়ে পাস করার সময় তুমি কি পেয়েছো? A crack blip. হ্যাঁ, crack blip means are you a thief? No. What happens to that archway? What happens to that archway? Always infrared light is falling. Always infrared light is falling from here to here. From here to here. Infrared light is falling always from here to here. From here to here. From here to here. And there is a detector here. Say for example, there is a detector here. Now, when you pass through this, if you want to pass through this, you are obstructing the light. When you are passing through this, you are passing through gate. Say for example, a gate. You are passing through gate, and from upside the gate, infrared ray is falling. So you are obstructing the infrared ray. So when you are obstructing the infrared ray, then current is not flowing here, and you will find a blip. You will find the alarm. And this gate, what is the function of this gate then? This gate is counting that one person is entering into the gate. And at the end of the day, say this gate will tell you that 500 person was passing in the gate. In the airport, in the shopping malls, this gate tells you that one person is passing through the gate. You can count money. You can count money in a money counter machine. You saw it in the bank. A money counter machine, a stack of money kept in the money counter machine, and it is just coming one after another, and money is counted. How? Say for example, these are the money, and infrared light is coming through this way. Infrared light is coming through this way. If a note comes, then infrared light obstructed. If a note goes, then infrared light is flowing again. If a note comes again, the infrared light obstructed. If that goes here, then infrared light flowing again. So if the instrument can count the number of obstruction, If the instrument can count the number of obstruction, then it can count the money. So there, say for example, there are five nodes. Number one, it is coming and it is obstructed the infrared ray and it is going. So one obstruction, two obstruction, three obstruction, four obstruction, five obstructions. You will get five. You will get 5 nodes. You can count 5 nodes. So these are the applications of photoconductivity. This is called photoconductivity. These are the applications of photoconductivity. তোমরা বুঝেছো?